Welcome, and thank you for joining this webinar, Wireless Driving the Automotive Machine to Platform Transformation, prepared by Alpert Research Team. Today, we're exploring one of the most profound shifts happening in the automotive world, the transformation of vehicles from mechanical machines into intelligent, software-defined platforms powered by wireless technology. Let's shift gears now to the how. Let's break down this wireless toolkit. It sounds like it's not just one technology, but a whole ecosystem working together. Where do we start? Maybe the long-range connection.
Good place to start. The foundation for wide-area connectivity is definitely the cellular networks. We're talking 4G LTE, increasingly 5G, and eventually 6G. This is the pipe for things like telematics, sending diagnostic data back to the manufacturer, downloading those huge HD map updates, connecting to cloud services, and critically enabling those over-the-air software updates, OTA.
And you mentioned 5G is really a key enabler for the next steps, especially autonomy. What makes 5G so different, so much more capable than the 4G we mostly use today?
It really comes down to three core improvements: latency, bandwidth, and connection density. For autonomous driving, particularly higher levels, you need incredibly low latency. That's the round-trip time for a signal car to network back to car.
How low are we talking?
The target for critical functions is generally under 10 milliseconds end-to-end. 5G technology is designed for ultra-low air latency, potentially under 1 millisecond just for that wireless hop. This speed is absolutely vital for safety-critical systems. Think about cooperative maneuvers between two autonomous cars. A delay of even a few dozen milliseconds there could be disastrous. Bandwidth is the other piece. Autonomous vehicles with all their sensors, LiDAR, cameras, radar, they generate just enormous amounts of data. We're talking potentially up to 10 terabytes a day for a fully autonomous test vehicle. It's massive, so if you need to download large, high-definition map updates quickly or stream sensor data for cloud-based processing or analysis, you need the kind of multi-gigabit speeds that only 5G can reliably deliver over a wide area. It ensures the car's brain has access to the latest intelligence almost instantly. 6G is targeting initial rollouts around 2030. The speed targets are astronomical terabits per second, and latency aims to drop even further down to maybe 100 microseconds for the air interface. But perhaps the most revolutionary concept in 6G is something called Integrated Sensing and Communication, or ISS.
ISX. What does that mean in practical terms for a vehicle?
Well, think about today's cars. You have separate systems for sensing the environment radar, LiDAR, cameras, and separate systems for communication, like V2X or Cellular. ISAC aims to merge these. The idea is that the 6G network infrastructure itself wouldn't just carry data, it would actively sense the physical environment at the same time, using the same radio waves.
So the communication signal itself becomes a sensor.
In a way, yes. The network could help with advanced environmental monitoring, detecting objects, building shared maps of the surroundings. For a vehicle, this offers incredible redundancy. The car could effectively see its surroundings using the communication network, complementing its onboard sensors. This dramatically boosts the reliability and safety needed for highly autonomous systems, maybe even L5. It's also key for those futuristic applications like holographic displays we might see later.
Vehicle to everything, or V2X.
V2X is a potential lifesaver. It covers vehicle-to-vehicle, V2V, vehicle-to-infrastructure, V2I, like talking to traffic lights, vehicle-to-pedestrian, V2P, and vehicle-to-network, V2N, which overlaps with cellular. The key benefit is extending perception beyond what the car's own sensors can see.
Like seeing around a blind corner.
Exactly that. Or knowing that a car several vehicles ahead just slammed on its brakes, even if you can't see it. It enables true cooperative driving. Some studies suggest that if V2X is implemented effectively, it could cut accidents by as much as 80%.
There's been a bit of a standards battle here, hasn't there, between the older DSRC standard and the newer cellular V2X, CV2X. Where has the industry landed on that?
Yeah, that's been a major discussion point. But the overwhelming trend, certainly in major markets like the US and China, is convergence towards cellular V2X, CV2X. The main reason is that it leverages the existing and rapidly growing 4G and 5G cellular infrastructure. CV2X has two main ways of working. There's the PC5 side link. This allows vehicles to talk directly to each other, V2V, with low latency, even if there's no cell tower nearby. Think of it as a direct walkie-talkie link. Then there's the UU link, which uses the regular cellular network for V2N communication, connecting the car to the cloud or infrastructure via the cell tower. CV2X is also part of the overall 3GPP cellular standards roadmap, so it has a clear evolution path towards 5G V2X and beyond.
So CV2X seems like the winner strategically. But you mentioned challenges.
The big one is fragmentation. While the US has pivoted strongly to CV2X, allocating the necessary spectrum, the older DSRC standard is still deployed in some places, particularly legacy systems in parts of Europe and Asia. This means global automakers often have to design vehicles that can support both standards. That adds complexity and cost, potentially increasing compliance costs by up to 15% just to handle these different regional requirements. It's a significant hurdle for truly global platforms. So what does this all mean? The message is clear. Wireless is no longer an add-on. It is the infrastructure of modern automotive value. If you take away one thing from this review, let it be this. Wireless is now the central nervous system of the automotive industry, and mastering it is essential to driving the future of mobility. Interested in gaining a deeper understanding of the transformative power of wireless technology, join the Alpert research team's webinars to explore cutting-edge wireless innovations, their applications, and their implications. Click the links below to learn more.